let me say it's a pleasure to be with you here and see so many familiar faces that have attended our New England Paving Conference. And also, hopefully I'm going to help perhaps most the unfamiliar faces, the folks that are selectmen and new folks to being responsible for roads, because that was my charge, was to come up with a program that would be very introductory and very basic, not complicated, not complex, and get right down to the basics of where asphalt comes from, how many types and grades there are, and the kinds that you use here in Vermont. And that's kind of what I put together today. And if you refer to your handout materials, Hank was kind enough to order from our headquarters under our new operational procedures. We used to be able to give these out gratis, but unfortunately they have to all come from our headquarters now. And he had a surface treatment tips in there. Now that publication in itself would make perhaps a half-day seminar. So we're not going to get into surface treatments in that much depth, but I thought it was the one that you'd have most use for in terms of reference when you get back to your offices at home. The other two items that I'd like to draw your attention to are whiteface bond paper, two typewritten items that look like this. One is titled The Refining Process, and the other is titled Pavement Maintenance Treatments. And if you kind of just keep them there on your desk, I think my slides are going to be clear enough when we put the floodlights out that you'll have a flow with me as we go through these things, and I discuss with you where asphalt comes from, and then I actually detail for you the many ways in which it is used. On this pavement maintenance treatments, it's something that we don't produce at our headquarters. It's something I did locally, and by taking an informal survey of the experience of a lot of highway superintendents and tried to estimate for you the service lives of these various treatments. And of course it depends on the road you put it on, as we saw this morning. The better the road, the longer lasting the treatment. And I detail in there, in that verbiage, as I will in the slides. You don't have to write anything down or take notes because of it. It'll be more or less a narrative script of what I'm going to cover, not word for word, but with the slides amplify on what we say here. So when you go home, you'll have a pretty good chance of understanding any term that anybody throws you with respect to asphalt and, you know, the treatments, prime coats, tack coats, seal coats, armor coats, what have you. And there's a lot of terms. And you'd have a reference handy in your desk that you could refer to. I think it's easy to read. I think any layman can read it. You don't have to be an engineer. And I think it'll give you a good yardstick to communicate, if you're a selectman, to communicate with your highway superintendent on what he's proposing to do, how long he thinks it'll last, and whether that's in fitting with your program and you're going to have the funds to do it, or perhaps you want to spend more money and go for something with greater longevity. Now you'll be able to judge which treatment gives you the longest run for the money, or the optimum, as we're all reaching for. So without further ado here, I think I'll get on the slides. Did I shut it off, or is it on now? Okay. We're going to have all up-to-date slides in this presentation. And if we were doing this 50 years ago, the story probably wouldn't change much, except the focus was different then. And it was still the concept of how to do it right. And the problem, however, at that time was different. It was getting the roads built, not maintaining them. And nowadays, what we're talking about really is focusing on the roads that, under the auspices of the Federal Highway Act, the federal gas tax combined with a dedicated state gas tax, we got the beautiful interstate system that we have in Vermont, which incidentally I think is just nip and tuck with New Hampshire, but I have to say probably Frank from the Vermont AOT agrees with me. It's the best, and it's certainly, I think, one of the best in the nation. I don't know, I haven't traveled outside of New England that much, but I would certainly say in New England it's just a delight to travel it. I came up last night. It was a full moon, good weather, I grant you, but the ride was delightful, Frank, and much to your credit, and also the side roads that we'll be seeing today in the slides. So we got the roads built, and we got a heck of a lot of mileage, and now we have a lot of traffic, and a lot of it's getting generated onto the town and local level. It's been pointed out thoroughly in the first presentation by Lynn Irwin, and I'm not going to belabor these points as much as I have in the past. In the past, we could get away with pothole patching, just go out and throw a little coal mix in and let it ride and try to get away with potholes. But even over in the state of Maine, they're looking for seminars and information like this. And this slide I took there this past April, where we actually had a hands-on demonstration as part of the seminar. In the afternoon, we had 3 different types of contractors come in and lay out their product side by side here. The one furthest to your right is called a sand seal. We'll be talking about that. And then the chip seal, probably the most common used in Vermont, and then what a slurry seal is. So the selectmen and highway superintendents that had heard about these products but probably hadn't seen them had a chance to actually visually see them go down, get a chance to feel them up front, see what they were getting for their money. So that's what we're going to try to do today, only with slides only. And the reason is we're trying to prevent this, because that's what's down the road if we don't do something to seal the roads. With or without bad drainage, if you don't do something, this is what you're eventually facing after a bad winter. Or, much worse, something we call, my favorite slide, too little, too late, and you're really facing something that you probably should think about heavy overlay or recycling altogether. Just go in and rebuild it, because there's too much work to prepare it for sealing. So the presentation I brought with me today was one that really is in 2 parts. The first part matches up 3 of those pages, the refining process and where asphalts come from, so you can kind of understand why you choose different processes for different conditions. As the charts show, all asphalt that we use for road paving today comes from crude petroleum. It comes out of the ground. As you can see, it's brought to the refinery tower where heat that runs all the way from 1,000 degrees at the bottom up to about 350 near the top apply different temperatures to the product, and by that process, different products of different volatility are gathered off. At the top of the tower, where the temperatures run in the range of around 350 to 400, the gasolines are taken off. And then the next product is solvent naphtha, which we mix with asphalt, but it has about the volatility of gasoline. And then further on down, there's furnace oils and then kerosene. And then you go on down further into the heavier diluents, the heavy oils and the gas oils and the heavy lubricating oils. And below that, well beyond the 600, 800 degree range, the product that's left at the bottom is further refined into asphalt. And the basic product we're talking about in all of these processes, the thing you don't want to get confused about as we cover a lot of ground today, is asphalt cement is the final product. That's the thing we're talking about. At room temperature, it's like hard bubble gum. Very hard, difficult to move or leave a thumbprint in. And in order to use it, we have to liquefy it. No matter how we use it, we either have to heat it up when we're making hot mix, or we have to put diluents in it, or emulsify it as we do with latex-based paints in order to get to use it. But the primary product we're talking about is asphalt cement over here. That's the pure product. And what we're going to see is that in order to liquefy it for purposes other than hot mix, which is about the only usage we can use pure asphalt cement for, with a couple of exceptions, but in order to use it for many of the procedures you see used in Vermont, you have to liquefy it in a different way than heating so you can use it at ambient temperatures. And the way they do that is by taking asphalt cements and making so-called liquid asphalts. Let me just step ahead a slide or two and we'll come back to this. I think it'll more clearly show you what we're talking about. As I mentioned, asphalt cement's a semi-solid, and it's usually a product of the distillation of crude petroleum. There are 3 basic types: the pure asphalt cement, a type known as cutback asphalts, used heavily here in Vermont for years, and emulsified asphalts, kind of coming on a little bit newer and fresher, and we'll talk about the reasons why you hadn't used as much emulsified asphalt before as you did cutbacks, and why we're encouraging you to use emulsified asphalts more and more and eventually eliminate cutback asphalts. The reason we have so many asphalts, types and grades, and you're going to see all told about 16 different types by the time we're done today, is to control the viscosity, because that's the characteristic that affects most how efficiently we can mix the material with the aggregates we're encountering. For example, if we're trying to mix asphalt with fine sand, we're going to need something fairly thin to get it to coat and mix with something fine like talcum powder. On the other hand, if we're working with good crushed rock material like you've got a bounty of here in Vermont, you can tolerate a little heavier material. You can tolerate a more viscous material to mix with something coarser. So you need a range of viscosities, and that's one of the reasons that we also have so many for. Okay, now to liquefy the asphalt and get it to the viscosity that we want, there are three different systems. We can do it by heat, by simply taking the asphalt cement in a pure form, that is, it has no cutter or no diluents added to it, and heat it up, as we do with hot mix construction. And we simply get it up to about 275 degrees, and it goes from hard bubble gum to a thin fluid. It'll coat aggregate in the hot mix plant. On the other hand, if you've got a cold mix plant, or you're going to do some kind of a surface treatment, you're probably going to want to spray asphalt at lower temperatures than 275 and do some work with it at ambient temperatures, more like 75 degrees. Then you're going to have to take the hard asphalt cement and blend it with a petroleum solvent, or you're going to have to emulsify it with water. And to get back to our chart again to see how that's done, as far as cutting it back goes, it's simply a matter of blending back some of the original products that we took out of the crude petroleum. If we want to make a rapid curing liquid asphalt, something that we want to put down like a tack coat, and we want to spray it on the ground and we want it to cure right away, we want to put something in there where the diluent will evaporate right away. So we use gasoline, and we make a rapid cure. That controls the type of the asphalt. If, on the other hand, we want to make some mix out in the field, want to grade blade it, move it around, or stockpile it for pothole patching, then we're going to take the asphalt and mix it back with some kerosene and create what they call medium curing liquid asphalts of the cutback type. And finally, if we're just going to go out and take our dusty roads, as Lynn showed this morning, and want to put a little dust palliative on them, or we got a seasonal road that we want to road oil, as we used to call it, we want to put a fairly thin asphalt cut back with a very slow curing material, like heavy oil. In this way, it has time to lay on the dust and the gravel and penetrate down into it. It doesn't cure out. If we used a rapid cure, it would just sit on top, create a flap, and wear off. Be the wrong choice. So this gives you some idea why we need three different types of cutback asphalts. And as I say, this whole family now is cut back because you can see why they're made that way. They're cut back from the original asphalt cement. Now there's another way of liquefying asphalts, and that's by emulsifying it with water and an emulsifying agent, generally soap. And this is a special procedure which we'll cover in a little bit of detail after we get through with a little more discussion about cutbacks. First of all, I mentioned to you that there are three different grades of asphalt in terms of the way they cure out, RC, MC, and SC, as you can see here. And then I said that the viscosity is very important also. So in the cutback range, we have 5 different viscosities. And the reason, as I'm sure you can see perhaps, if you're doing something like dust laying, that's the kind of material you want to use, something very thin that'll penetrate in or prime. On the other hand, if you're making some cold stockpile patch mix, for pothole repair, you want something with a little bit more sturdiness to it, a little more asphalt in it, but yet alive enough so that stockpile stays alive all winter long so you can use it. So you use MC250. If you use MC3000, you wouldn't be able to touch the pile. It just wouldn't move, wouldn't be workable. So we need this range of viscosities on the cutback grades for those reasons, and we'll tell you why in a minute. Now getting on up to the emulsions and how they're produced, and to give you a hands-on idea, I'm sure everyone's sealed his driveway at one time or another or worked with somebody that did. That's about the closest that you'll have hands-on experience with an emulsion. Those are generally all tar emulsions. Some are asphalt emulsions also. But it's basically a suspension of the asphalt in water with a soaping agent, and that's what keeps it in solution. That's so you can work it or add water to it if you want. Sometimes even mix some sand in with it if you want to make a little patch material on your own. Why are we pushing emulsions today and trying to squeeze cutbacks out? Well, as you've seen from the slides, we achieve the same objective. We get the asphalt cement liquefied, but it saves a tremendous amount of energy. Because when the cutbacks are used, all that gasoline and all that kerosene has to evaporate away into the atmosphere in order for the asphalt cement to finally do its job. Otherwise, it won't perform well. You've got to get rid of it. So you're really wasting it to carry the asphalt cement to the job. The other is we believe we get better aggregate coating and can manage aggregate coating better with emulsions than we can with cutbacks. There's no fire hazard because in every case with an emulsion, you're working at well below the boiling point and never reach what we call the flash point, which you can reach with cutbacks. When you're using a product that has gasoline mixed in it and you're spraying it at about 300 degrees, believe me, you've got a good chance for fires, and there are some that have happened, and explosions. So emulsions are much safer to handle. And then finally, we have environmental concerns, perhaps not so much here in Vermont, where you got plenty of good clean air, but it affects overall our efforts to clean up our air, and by not allowing those volatiles to escape, it doesn't create ozone. When you have water escaping, there's no ultimate harm whatsoever. Maybe you raise the humidity an immeasurable amount. This shows you how the emulsions are made. Simply with soaping agents and water, they make an emulsion slurry. Is that in focus? Okay. And the asphalt cement is heated up so it's reasonably fluid. And they bring the materials together in a colloid mill. The emulsion suspends the asphalt globules. Sometimes they add in a little bit of oil to make the emulsion a little slower curing, and also assists in coating some dirty aggregate. And then the final product ends up in the asphalt emulsion tank. And you've got a material which I know a lot of you are unfamiliar with. You're afraid to try. But believe me, once you have tried it and worked the way you should with it, and we could cover perhaps in more detailed programs later, you'll be more pleased with it. The particles of asphalt range in size in the mixture, and when someone first sees it compared to cutback asphalt, say on a chip seal, they get a little panicky because it looks such a chocolate brown instead of the very sheeny black that the cutbacks have. But that's the natural color of a good emulsion, and I'd be concerned if it didn't look that color. And it's just the cause of the water that's in there that gives it that coating. As this cures out during the day, it would turn a dark black. Now, sometimes I think that the whole progress towards using emulsions has been held up simply by the way that they've been marketed in a proprietary way, and the fact that they use so many different emulsifiers for them. It creates so many grades and brands, it confuses people. And one thing we have to point out is that in the emulsion grades, there are two types. One is negatively charged because of the kind of emulsifier they use, and they call them anionics, and the other is cationics, and they're positively charged. Ignore number 3. I kind of wish they left it off the slide. We don't even refer to them in our standards. One way to remember this, the cationic is positively charged, the T reminds me of the plus, and anionic is anti. It's important when you're making coal mixes to know whether or not the emulsion you are going to use is going to mix with the aggregate source you're using. And that's why it is important to identify the 2 different types. With respect to how they handle, like cutbacks, they've done the same thing with emulsions as they've done with cutbacks. They've made them so you can handle rapid setting situations by creating a rapid set. The anionics are called RS, rapid set, simply RS. The cationics, CRS, or cationic rapid set. And so on down the line, the medium setting, MS and CMS. And there is one more fluke, as I say here, because of the proprietary activity in emulsions. And this has been identified recently by AASHTO and others, and we have to acknowledge it too. But it's really nothing more, and I kind of wish they had put it up here in parenthesis next to a medium set. It's a product called high float medium set emulsions. And the only difference is that when they run a test on the asphalt cement that's used, there are different properties that are measured. The proponents of the product claim different kinds of virtues of performance with it, and we always have to defer those claims naturally to their own documentation. We don't have any to document one way or another. If you use a high float medium set, you're going to get that much better performance than if you use a MS or a CMS. So just remember the last words, really. It means it's a medium setting material and good for mixing. Medium sets are generally used for mixing. Rapid sets are generally used for surface treatments. Now, referring back to the handouts that I gave you, what I tried to do in those handouts is very summarily for you on page 2 of the one called the refining process, paste together there something that didn't appear in our publications, and I thought it was very handy for you to track it down. And if you look at it, and I don't have a visual to refer to it, but if you kind of just glance at your handout, I have located up in here the asphalt cements, all the types that are used across the United States, the pure asphalt cements. If you come down here, you'll have the rapid setting, the medium setting, and the slow setting asphalts listed so that you can see where they come off in the refining process. So you're going to have a good idea when you get out of here today, and you keep this for reference, where all these products come from and how they're made. Because it does affect their handling characteristics, and you need some basic understanding of which kind of product you're talking about. On the final page of that handout, on that particular, or excuse me, so it's next to the last page, at least in my series, there's a table, a very elaborate looking table. You couldn't even appreciate what's on it by looking at this slide. It's much too busy. But essentially what it does also for you is identifies all the asphalts that I introduced you to today. It identifies all of the methods that you use here in Vermont for maintenance, and it tells you what type and grade of asphalt I generally recommended for that practice. Therefore, if some salesman comes in and tells you you're going to use something different and there's no little check mark in the box, at least you've got reason to question what the procedure will entail and make him document performance on that basis. That's perhaps the most heavily used item in my office. I keep it in a plastic sheet. For handy reference, I'd recommend you do the same if you have to make some decisions on what you're going to do and which surface treatment you're going to pick to maintain and seal your roads. Sand, chip, slurry, and we'll see even more now. Now, we said we had to liquefy asphalts to use them. And in order to do so, and then use them effectively in the field, for most maintenance treatments that are conducted in the field, the piece of equipment that does that is the asphalt distributor. Nothing more than a big tank truck with baffles so the stuff won't slosh around, and flues that run through it so heaters can direct heat in here and get that asphalt that you've chosen to use up to the right spraying viscosity, so it's just the right consistency such that when it comes out of the bar, it puts down a heck of a nice even film on the road, and that's the beginning of a good job. So that's the key, understanding the equipment and picking the right material so you get the right viscosity.